In 29, we have r of t equals 10 raised to power 2 the square root of t. Okay. Perfect. So when we differentiate this, here's how I look at it. Okay, r prime is 10 to something, 10 to a function. How do I differentiate 10 to a function? Well, I have 10 to that function times natural log 10, because it's not e, times the inner function prime. But when I differentiate this, I get 2 times 1 over 2 the square root of t. All I have to do is just simplify. And this is it. I will rearrange it as 1 over the square root of t. I can put the 10 to raised to 2 the square root of 10 to the square root of t times natural log. I can keep it in the numerator, so it's not confusing, and that's the answer. See if you have any questions on this problem. Okay. Would you like to choose anything else? So 31 is the same long type of problem because we need to fully simplify it. But this time is a quotient. It's exactly what we just did, but it's a quotient. So 31. Is there anything else you would like to choose? 33 is an interesting one. T times sine 2t. '43 is an interesting one. 45. So
can we do something that has e to the power but has a coefficient of e?
a coefficient of e.
Does that make sense?
Coefficient.
I'm not seeing any, but they were
something like this, you mean? E to sine squared of x squared?
That's not what I was going with, but we can go with that one. I have a different question I can ask later.
Yes, no. If you want to make one up, that would be great. So f of x equals e raised to sine squared of x squared. Okay, perfect. So we are differentiating e to a function. E to a function prime. What do I have to write? Can anyone walk us through? Anyone, please? The formula for e to a function prime.
Would be e to that function.
Okay, very good. Stop for 1 second. Awesome. Times the inner function prime. But it's a lot. This is number 1, this is number 2, and this is number 3. This is not a simple thing to differentiate at all. So now here, first I have to differentiate the power. Bring the power down, multiply by sine to 2 minus 1 of x squared times the inner function prime cosine of x squared times the innermost function prime 2x. It's a mouthful.
Could you go through that, like inner prime, like could you go through that slowly for this one?
Of course, I'm going to do it separately and then I'll come back here. So forget about e to that. So let's do this first. Sine squared of x squared. We want to differentiate this. So first, I differentiate the power. So I have 2 times sine of x squared to 2 minus 1 times the inner function prime, which is cosine of x squared, times the innermost function prime, which is times 2x. So I have here, this is number 1, this is number 2, and this is number 3. So I differentiate the power, 2 times sine to 2 minus 1, times the inner function prime, which is cosine of x squared, times the inner function prime, which is 2x. So then coming back, I have the 2 with 2x, so I have 4x. I have sine cosine times e to sine squared applied to x squared. So you have to continue till you exhaust all functions in the problem. So first I have to start with this, then I have to differentiate the inner function, and then I have to differentiate the innermost. So 2 sine to 2 minus 1 times the inner function prime times the innermost function prime. Is this better? Please say something, anyone? Is this better?
Yes.
Awesome. Okay. Amanda, did you come up with a problem that you wanted to look at? You said something with an exponent or something, I'm not sure. Can you make one up? Just make one up.
Okay, so I have one from the homework. So y equals 4 e to the power of x plus 7 divided by the cube root of x.
Perfect. That's it? Okay, I don't like this, but I like this. I don't ever want to see something like this in the denominator.
Could you switch back? You're still presenting.
Of course. Thank you so much. So I'm not going to differentiate this. I'm going to differentiate 40 to the x plus 7 x to negative 1/3, like we did before with the previous example. It's one of them, like half an hour ago. I don't remember. So then y prime, when I differentiate this is just plain 4e to the x. I have to bring now negative 1/3, so I get negative 7/3, and x, negative 1/3 minus 1, negative 4/3. This has nothing to do with the chain rule. This is just plain and nice differentiation.
I was struggling because the 4, like the 4 and the 7, both appear to be coefficients. But the 7...
But they are two different functions. This is one function plus another function. They have nothing to do. 4 and 7 have nothing to do with each other.
Right, but the 7 gets multiplied by the power of negative 1/3.
Because this is a different rule than this. This is the power rule, and this is just simply differentiating e to the x, which is e to the x.
Okay, so e to the x is e to the x. I've got that. But if e to the x has a coefficient, then it's still just the coefficient e to the x. That coefficient does not change.
Because we have this rule. A constant times the function prime is the constant times the function prime. As long as the constant is a factor, it doesn't affect anything. Is that okay? You see that this is a constant times a function.
Mm-hmm.
So the rule for a constant times the function prime is the constant times the function prime.
But then with the other function, is that not 7 times the cube root of x?
But
sorry, 7
but when we differentiate this, 7 is still there. We're not doing anything to 7. We're only bringing down the power negative 1/3 because the rule is the power rule. But 7 is still there, like 4.
Mhm.
7 didn't go away. We didn't do anything to 7. We just had to multiply it by negative 1/3 and it becomes negative 7/3. But the 7 didn't go away. The 7 stays, like 4 stays. If you don't want to write it like this, you can write it like this. Negative 7 times 1/3 times x to negative 4/3. We don't write it like this, but you can. So 7 and 4 have nothing to do with anything.
Okay.
But we don't like to write it like this because we write it as negative 7/3. Is that okay?
Yes, thank you.
Thank you. Do we have other questions, other problems, or we go back? Anyone else? Okay, so let's go back. I think we had enough. Maybe we can look at some other problems now. Of course, find the equation of the tangent line to the curve at a given point. The same theme over and over, over and over. So let's choose one. Anyone? I will choose 59. And 59 would have y equals sine applied to sine x at pi comma 0. So we have y minus y1 equals the slope times x minus x1 using the point. The question is, how do I determine the slope? Anyone, please?
Redifferentiate.
Right, and plug in pi.
And plug in.
Yes. So can anyone help with differentiating this function, please? Outer, inner. Anyone, please? Y prime equals
It's going to be sine
prime. Yes.
times sine.
Nope, it's not times. It's sine of sine x. This is sine applied to sine. This is the outer, this is the inner. So let's differentiate the outer. What do we get when we differentiate the outer?
Oh, cosine?
Cosine of the argument, awesome, times the inner function prime.
Cosine.
Very good. This is it. Now I have to plug pi in it. Y prime when x is pi. So cosine pi. I'm sorry. Sine pi, I meant to say. Sine pi is
0.
excellent. Cosine 0,
1.
excellent. Cosine pi,
-1.
so this is -1. Awesome. So this is y equals negative x plus pi. Y minus 0 is y. -1 times x is negative x. -1 times -5, pi is plus pi. This is the equation of the tangent line to the graph of this function at pi comma 0. Awesome. Okay. I'd like to look at a table. Yes, any questions, please? Anyone? Any questions? Any questions? Okay, I'd like to look at a table. We haven't used the table before. We looked at graphs, we determined slopes and stuff, but we never used the table. So let's use a table. A table of values of f, g, f prime, and g prime is given. So let's choose A or B. You choose A or B.